On proof number 33, I'm going to start by marking on the picture with what I know. I know that x, y, and yz are congruent, and I'm going to mark in purple what I'm trying to find, because then when I look back, anything in purple I don't know yet, but that's where I'm trying to go. The first thing I notice is that if I have an isosceles triangle, XYZ, is that I can draw a cross to angle 2 and draw a cross to angle 3, and those two angles have to be the same because of that isosceles triangle. Well, then I notice that angle 2 and angle 1 have to be the same, so I can mark those the same, and angle 3 and angle 4 have to be the same, so I can mark those the same. And I'm pretty much finished with this proof. 1 matches 2, and 2 matches 3, and 3 matches 4, so 1 matches 4 by the transitive property. So now I need to write down everything in my proof that I just said. So I started with my given information that xy was congruent to zy because it was given to me. The next thing that I marked was that angle 2 was congruent to angle 3, and I said that was because of the isosceles triangle. The way we've been writing that theorem is if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So that gave me 2 and 3. The next thing I noticed after that was my angles 1 and 2 had to be the same, and then my angles 3 and 4 had to be the same. And I noticed that because I recognized the vertical angles. So those are congruent because I know that vertical angles are congruent. And since they both are a pair of vertical angles, I can list them under the same statement. And that was everything that I needed. If 1 matches 2, but 2 matches 3, and 3 matches 4, then angle 1 is congruent to angle 4 because of the transitive property.